All right, so we're going to start chapter 3, section 1. This section is going to tie kind of into what we just did in section 2.5, but we're going to focus only on quadratic functions for this lesson. You'll notice that a lot of the material is a little bit similar, but we're going to have different ways of solving for more specific information as opposed to just perform the transformation and graph accordingly. All right, so we're going to get a little bit more specific. So as you all know, the graph of a quadratic function is going to look like this U shape that we call a parabola, right? And so one thing about this book that's a little bit different from what I've taught you is that they call this quadratic form, so this ax squared plus bx plus c, they call this quadratic form, but I taught this to you guys as standard form, right? So this is the standard form of a quadratic. Right. I taught this to you as a standard form. This book considers standard form something else later on in this lesson that I call vertex form. Right. So it's a little confusing, but on a test or a quiz, you guys aren't going to have to worry about the ambiguity of that because we'll let you know ahead of time in the directions whether we want it in this form. We'll write out exactly it looks like this, or it'll look like the other form that we'll learn today. So let's look at what consists of this parabola. We have a vertex right here, and it's always going to have the coordinates h comma k, right? So we can see that it's right here somewhere, and we denote that as hk. We also have this imaginary green dotted line or dashed line, and this takes the equation of x equals h, right? So our h coordinate of our vertex. This is called the axis of symmetry, and what this is basically saying is that our parabola, we can split it directly in half, and then at this line, we're going to have on one side of our parabola is going to look exactly like the other side of our parabola. Right, so they're going to mirror each other exactly across this line. So now to graph an equation in quadratic form, we want to find the vertex using this little formula right here. It's negative b over 2a. It's written kind of strangely in the notes. When I write it, it's going to look like negative b over 2a like that as a fraction. Right, and then we're going to take this number, whatever you get from it, and we're going to plug it back into our function to find our y coordinate of our vertex. To finish the graph of it, you're going to want to find the y-intercept. And if you need any extra points, we can plug in any random points. So we can maybe pick values like 1, 2, 3. Plug it into x, plug it in, replace x with those values, and then find the value of y that you get from it. Or you can use the x-intercepts. I would use the x-intercepts as much as you can just because that's probably one of the things that we're going to ask you on a test or a quiz is to find the vertex, axis of symmetry, x and y intercepts, right? So you need both intercepts. Okay, I'm not going to spend too much time on this slide or the next one. Really, something like this ties more into the previous lesson in terms of like the stretching and the shrinking. For this one, we know that this is a parabola. It's going to look something like that, right? That's our parent function. Looks something like that. And our stretch, right, in this case it's a stretch because 2 is a number that's bigger than 1. And it's being multiplied to our function, and it's going to stretch. It's going to look something like that. Right, it's going to get a lot longer, right, something like that. You can use points, plug it in if you want a more exact graph, but this isn't the focus of this lesson, right? This is just a little bit of review. This 1/2 x squared, this f of x, also is a parabola. It's going to look something like that. And this 1/2 denotes a vertical shrink, right? So it's going to widen our graph a bit. It's going to look something like that. Again, pick some exact points if you'd like a more precise graph, and that's fine for now, right? We're going to actually graph in a more proper manner, right, in a couple minutes. All right, so same thing here. Right, more parabolas that I'm not going to get into too much detail with, right? A parabola is going to look something like that, right? But this one, we want to both flip it and stretch it. Right, so you're going to flip it in the reverse direction. It's going to go downwards, and it's going to be stretched by a factor of 4. Right, so that means every single y value you're going to multiply by 4. Right, again, pick some exact points if you want a more precise graph. This isn't the focus of our lesson. Same thing with this next one, right? It's still going to be a quadratic, a parabola. All right, and facing downwards, right, because of that negative, and it's going to be stretched. A factor of 1/4 is going to be a really wide graph. It's going to look something like that. All right, and the smaller the shrinking factor is, the wider it's going to be, right? So 1/4 is a pretty small number, so it's going to become a lot wider. And the same thing with 4. Like 4, we've seen with a factor of 2, it stretches and it gets longer, but not crazy long, right? A factor of 4 is going to stretch it out a lot longer. It's going to make it really skinny. But again, you can pick some points if you want to test it out. We're going to really start the lesson in the next slide. All right, so if you recall, this is what I was mentioning earlier about standard form. You see at the very top, it says standard form, but it doesn't look like the ax squared plus bx plus c that you're used to. Right, so our book calls it something different. I call this vertex form. All right, so this is our vertex form of our quadratic. And I'll tell you what each piece of it means, right? So A is going to be the same A that's in our quadratic form, or our regular standard form. It's going to be the same A that's in your ax squared plus bx plus c. This is just the stretching or shrinking factor, or whether or not there's any reflections. It's going to be accounted for in this A. Now your vertex is going to be this point h comma k. All right, and we're going to have an axis of symmetry at the point, or no, crossing the x axis at h. All right, so it's going to be the same h that's in your vertex is going to be your axis of symmetry. All right, so let's use this information to graph a parabola. Right, so with no prior knowledge of this lesson, right, so let's say I didn't explain any sort of vertex form or anything, this should be something that we're able to graph, right? So we have an x plus 2 squared minus 3. We know that if a number is on the inside of our parentheses and it's being added or subtracted, it is a horizontal shift, and a number on the outside that's being added or subtracted is going up or down, right? So this one is going to be going down 3 and to the left 2, right, because there's a plus 2. So we should know that it's going to look something like this, right, something like that. All right. But let's scratch that, because now we're trying to get a little bit more specific, right? You can use this as a guideline to what we're trying to do, but we are doing it a little bit differently now, right? So you can use your transformations to help you in doing your graph, right? It's not, like, that's not a bad thing to do. But I'll show you a little bit more about what we're trying to do here. So let me go ahead and erase this. I'm going to specifically ask, in this question, find the vertex, right, axis of symmetry, right, and I'll throw in one extra point. I'll throw in the y-intercept, right? So this is what I showed you guys in class, right? And this is a little bit more aligned with what this new section is we're going to be asking you on, right? So we're going to be asking you to find these particular points. We might also ask for the x-intercepts, but for the sake of this example, right, you guys are just seeing this for the first time. I don't want to do that yet, right? We'll do that later on in this lesson, right? So in the same video, but not for your first example. Let's start by finding the vertex. Now this is in vertex form. Now if we remember, vertex form is this right here. It's going to be f of x equals a times x minus h squared plus k, right? So let's match everything that matches up, right? So we see that there is a plus 2 right here, and that matches this minus h, right? They're in the same spot. The same thing with this plus k, right? This plus k that's on the outside, it's in the same spot as this minus 3, right? So all you have to do is you're pulling the information from this function that you see here. We have immediately that our vertex is going to be this ordered pair -2, -3, right? Now, something to note is that it's a -2, right? It's a -2 and it's not a +2. Even though we see a +2 on the inside, we already know from our transformation section that if we're adding on the inside of parentheses, it's going the opposite direction, right? So it's going to be a -2. Another way to tell based on this section, right, and using this vertex form right here, our formula is x minus h, right? So if we're if we have minus a negative number, that's going to give us our positive number, right? So that's where this plus comes from. All right, so our vertex is going to be -2, -3. And like I said on the previous slide, from the vertex, we can immediately get our axis of symmetry, right? I'm going to abbreviate it AOS, right? Axis of symmetry. It's going to be this equation, x equals the x-coordinate of your vertex, so -2, right? And that just means, I'm going to go ahead and graph these. At -2, -3, we have a point right here, and our axis of symmetry is going to be this imaginary line passing through x equals -2. So again, let's say we don't know anything about transformations, right? So let's kind of flip it, right? Let's say we didn't know anything about the previous lesson, and we're trying to graph parabolas from scratch, right? So this is one way to do it. We have a vertex, an axis of symmetry, and let's find one more point. In particular, let's find the y-intercept, right? So graphically speaking, the y-intercept is going to be the point on our y-axis where our graph crosses, right? So mathematically then, to find our y-intercept, you're going to plug in x equals 0 into our function, right? So you're going to plug in x equals 0. And let's do that for this function. We have f of 0 is going to be 0 plus 2 squared minus 3. And then 0 plus 2 is going to get us a 2. We have a 2 squared minus 3. And 2 squared is going to give you a 4. We get 4 minus 3 is 1. Right, so we get our y-intercept is going to be this ordered pair of 0, 1. And then we're going to plot that point right there. Now, one cool thing about the axis of symmetry, right, and maybe we could have figured this out from the previous section, right? Maybe some of you were intuitively doing it. But notice that this axis of symmetry, it splits our parabola in the middle so that whatever's on one side of it is going to show up on the other side, right? So this point right here in blue, right, notice that it's 2 units from our axis of symmetry. That means 2 units on the other side of our axis of symmetry. We should expect to see a point right there. So some of these points, you can just use symmetry and determine your points that way, right? If you have one point, the y-intercept, you can easily find the corresponding point on the other side of it, right? So now we have 3 points, and this is enough information to sketch our parabola, right? So connect our dots. Connect our dots, and it's going to look something like that, right? And I didn't ask you guys in this problem to find the x-intercepts, right? But we can see that they're going to cross somewhere over here, right? Now, after doing that last problem, you guys are probably thinking, why would we want to do that when we can just use transformations instead, right? Using the transformations, you can graph your function a lot easier, right? Not always are we going to ask you guys just to graph it, right? In these ones, we're just graphing, right? But I'm trying to get you guys into the habit of finding every single part of the quadratic, right? So in the example after this one, we're going to be asked to find the vertex, axis of symmetry, x and y intercepts. If you just need a graph, you can graph it however you want as long as there's some accuracy to it, right? But in this section, the focus is, can we solve for each individual part of it? And if you look at something like this, right, this isn't even in any form where we can use transformations, right? So we have to use the knowledge that we're learning in this lesson to find that information, right? And I'll show you how to do that now. So we had said that for any quadratic that's in this quadratic form, so this ax squared plus bx plus c, to find the vertex, we want to use this formula x equals negative b over 2a, right? So I'm going to write over here, I'll actually write h, right? Because that's actually the coordinate of our vertex. It's going to be h equals negative b over 2a, right? And let's go ahead and label. I'm going to say that a is equal to 1, b is equal to negative 6, and c is equal to negative 14, right? So it's just the number in front of our x squared, our x, and our constant, respectively. All right, so let's go ahead and plug it into this formula right here. And so we get negative 6 over 2 times 1. All right, negative 6 is going to get you a positive 6, and 6 over 2 is 3. So we get that the x-coordinate of our vertex, all right, I'll write it over here. So our vertex, we have our x-coordinate is 3. To find the y-coordinate, or the k value, you're going to plug in 3 into your function, right? So we're going to have f of 3. That's going to become 3 squared minus 6 times 3 minus 14, right? And 3 squared is going to get you 9 minus 6 times 3 is 18 minus 14, right? And so we get that this is negative 9 minus 14 equals negative 23. And so the y-coordinate of our vertex is negative 23. So I'm going to go ahead and plot that point now. If we do it on this graph, it's going to go off the graph, right? It's way down there. So I'm going to change the axes. I'm going to make it go by 4s, right? So I'm going to make this a negative 4, negative 8, negative 12, negative 16, negative 20, and negative 24. All right, so I'm just going by 4s. I'm going to find 3, negative 23. It's going to be right here, right? So that's our vertex. And then, like I've been saying before, we can immediately, from this, find our axis of symmetry. It's going to be x equals our x-coordinate of our vertex, which is going to be 3. So x equals 3. All right, and that's this imaginary line right here that splits our parabola in half. All right, and now I want to find another point. I like using the y-intercept. Right, so to find the y-intercept, you're going to plug in x equals 0. Right, so we're going to have f of 0 is 0 squared minus 6 times 0 minus 14. And so we get negative 14. Right, notice that this is the same value that's right here. Right, so actually something that's going to make this a lot easier is anytime that you have a quadratic function in quadratic form or standard form, your y-intercept is always going to be 0, comma c, right? And the c is the number that's the constant, right, by itself. In this case, anytime that you plug in a 0, you're only going to be left with your c value, right? So our y-intercept here is going to be at 0, comma negative 14. So really, we didn't even need to write this down at all, right? And you won't ever have to, right? You can find the y-intercept given standard form just by looking at it, right, without having to do any math, right? So I'm going to go ahead and plot the y-intercept over here. It's going to be right here at 0, negative 14, so between negative 12 and negative 16. And then like before, I'm going to use the axis of symmetry. I'm going to take advantage of it, and I'm going to go 3 units in the opposite direction to plot another point that mirrors it exactly. And then what that's going to do is you're going to connect the dots, and this becomes your parabola. All right, so it looks something like this. All right, so here's another example, and this one we're being asked to find some more information, right? So on top of just graphing it, we want to find the vertex, axis of symmetry, and y-intercepts as before. This time we're also being asked for the x-intercepts, right? So we're getting a little bit more specific with the information that we're looking to find, right? So we're going to start with the vertex and axis of symmetry and y-intercepts, just like we've done for the previous ones, and then I'll show you guys how to do the x-intercepts, right? So to find the vertex, again, this is an equation or a function that's in our standard form, our quadratic form. So we're going to use the formula h equals negative b over 2a, right? So we want to label a equals -1, right? That's the number in front of your x squared, right? So -1, b equals 6, and c equals -8. All right, so hopefully we're comfortable with that by now. Right, so just plug these in. We're going to get this is equal to -6 over 2 times -1. Right, so this gives us -6 over -2. Two negatives make a positive when you divide them, and then 6 divided by 2 is going to get you a 3. Right, so when it comes to our vertex, right, so we're going to need to find our vertex, axis of symmetry, our y-intercepts, and our x-intercepts. Right, so for our vertex, we have an x-coordinate of 3. Right, now to find the other coordinate, you're going to take this 3 and you're going to plug it back into this f of x, right, to get your y value. Right, and remember, f of x, guys, is another way of saying y. Right, so f of x and y, they're interchangeable. So you could even just say y equals -3 squared. Right, it's whatever you're most comfortable with. They mean the same thing. Right, just plug in a 3 everywhere that you see an x. And then this becomes -9 plus 18 minus 8. Right, and then simplify this a little bit. We get that this is 9 minus 8, which is 1. Right, so our vertex is going to be 3, 1. So let's go ahead and plot that point. It's going to be right there. All right. Our axis of symmetry, right? As soon as you get your vertex, you can immediately find your axis of symmetry. It's always going to be an equation of x equals 3, right? If x equals something, right? So I can't recall if I mentioned it already in this video, but you need to be careful with how you answer these questions. If we ask on a test or a quiz, find the axis of symmetry, and you just say 3, you won't get full credit, right? Because we don't know what that 3 means, right? You need to label it. X equals 3 specifically represents the equation of this line that passes through, oh, I labeled it wrong. My bad. Okay, so it should be right here. 3, 1 is right there. Okay, so it should specifically be this line that passes through the x-axis at x equals 3. Right, so can't just say 3, right? Same thing with your y and x intercepts, right? You're going to have to write them as ordered pairs and not just the numbers, right? Because we need to be specific with the information that we're finding. All right, so we have that, and we can also find our x-intercepts. I'm sorry, not your y-intercepts, right? Because we said in the previous problem, we don't need to plug in 0 when they give it to you in quadratic form, in standard form, right? Because your y-intercept is always going to be 0, comma, your c value, right? In this case, it's -8. So we have 0, comma, -8 as your y-intercepts, right? So that means it's going to cross at this point right here. So I'm going to extend this graph a little bit. It's going to go off. It's going to be right there. All right. And now that we're here, let's use this axis of symmetry. Let's use symmetry to find the part that it mirrors, right? So 1, 2, 3 from the axis of symmetry, and we're going to go 3 in the other direction. 1, 2, 3, and we end up right here. Right, now, in any other situation, this would have been fine with me to graph your parabola, right? Just connect the points, right? Draw your little arrows, and then that's that, right? But in this case, we also want the x-intercepts, right? And so now to find the x-intercepts, right, think about it. If with the y-intercepts we set the x equal to 0, what do we think we need to do to find our x-intercepts? We're going to set the y equal to 0, or our function, right? So we're going to take our entire function, right? So to find our x-intercepts, you're going to set your function equal to 0, right? And this is the same as y equals 0, right? So remember, f of x is the same as y. So we're going to have -x squared plus 6x minus 8 equals 0. All right. And now we're going to try to solve this quadratic. And we should know how to solve a quadratic, right? This was from way back, right? So to solve this quadratic, there's nothing in front of this x squared other than this negative, right? So the easiest way to solve it is to try and get rid of it right away. I'm going to go ahead and multiply this entire equation by a -1, just so that when I distribute it, it changes the sign of everything and we get something that's a little bit easier to solve. So we get x squared minus 6x plus 8 equals 0. Right, now this is something that's factorable, right? Thankfully, we're able to factor this, right? If we remember how to factor, we're trying to find numbers that multiply to 8 and add to -6. And that's going to be -4 and -2, right? And now we use our zero product property, say each of these equal to 0. And then we get x equals 4 and x equals 2, right? Now in any case, in the previous sections, this was fine because we were just solving for x. In this case, we're finding x-intercepts, so you want to write them as ordered pairs, right? This is the same as 4, 0 and 2, 0, right? So under our x-intercepts, we found 4, 0, 2, 0. All right, so now let's go ahead and plot these points on our graph. There's going to be one point right here and another point right here. And now we're just going to connect these points. All right, it's going to look something like that. All right, and that's the sketch of our parabola. And this is all of its work. All right, so very tedious stuff, right? Let's not say it's difficult yet, right? Because this isn't crazy difficult math that we're doing, but it is definitely a lot more involved than the previous section that we were working on, right? Now we're getting very specific with the information that we're finding. All right, so we're going to try the same thing with this one. All right, so find the vertex, axis of symmetry, x and y intercepts. All right, so same exact process as before to find the vertex, right? So I'm going to go ahead and just leave a space up here just to put all of the information that we have. All right, so to find our vertex, again, this is something that's given to you in our quadratic form, our standard form, right? So I'm going to use h equals -b over 2a, right? Really small formula to memorize, right? So a is going to be in front of the x squared, b is in front of the x, and c is your constant, right? So this is going to be -4 over 2 times 1. So we get 4 over 2, and this is 2. Right, so the x-coordinate of our vertex is 2. To find the y-coordinate, just plug it back in. So we get f of 2 is 2 squared minus 4 times 2 plus 3. And then this is 4 minus 8 plus 3. This is -4 plus 3, which is -1. So our vertex is 2, -1. Let's go ahead and plot that point. So 2, -1 should be right there, right? Right, didn't make the same mistake as last time, right? So good. And so our axis of symmetry we just get from writing the equation x equals the x-coordinate of your vertex, which is x equals 2. Now, once again, you don't just want to write 2 if we're asking for the axis of symmetry. We have to write it as an equation of a line. X equals 2 is this line that passes through the x-axis at -2. I mean at 2, sorry. All right. And so now let's find our x and y intercepts. All right, as always, I'm going to start with the y-intercept because that one's the easiest to find given our quadratic in standard form. Right, so you're just going to use the c value, and that's going to be the y-coordinate, right? So 0, 3 is your y-intercept, right? And it's going to be right there. Again, no math necessary for the y-intercept if you're given in quadratic form, all right? And so we can use symmetry to find another point, right? So we know that this point is 1, 2 units from the axis of symmetry. So let's go 1, 2 units on the other side, right? So we have another point. All right, and now let's find our x-intercepts. And to do that, we're just going to set our function equal to 0. All right, And this is going to factor as x minus 3 and x minus 1, right? So we want numbers that multiply to 3 and add to negative 4. Like I said a long time ago, you cannot forget how to factor. It is never going away, right? So we get x equals 3 here and x equals 1 here. And we get our x-intercepts are 3, 0, and 1, 0. Right, 3, 0, 1, 0. All right, and plot those points over here. And then connect the points of your parabola. All right, and that's all you need for this problem. All right, let's try another one like the ones that we were doing. Let's start with finding the vertex, right? So we want to use the formula h equals negative b over 2a. All right, let's label everything. A here is 2, b is 8, and c is 7. Right, so we get that this is equal to negative 8 over 2 times 2. And we get negative 8 over 4, which is negative 2. All right, so we get our vertex. Right, let me write it the same way that I've been doing it before. Right, let me just leave a space to write all of our answers. All right, so our vertex, we know that the x-coordinate is negative 2. Now to find the y-coordinate, plug it back in. So we get f of negative 2 is 2 times negative 2 squared plus 8 times negative 2 plus 7. All right, and negative 2 squared is 4, so we get 2 times 4 minus 16 plus 7. And we get 8 minus 16 plus 7. And this is negative 8 plus 7, which is negative 1. All right, so our vertex is negative 2, negative 1. Let's go ahead and plot that point. It's going to be right there. Now again, immediately you can find your axis of symmetry. It's going to be the equation x equals negative 2. Again, not just negative 2. You have to write x equals negative 2. All right, and it's going to be this imaginary line right here. All right, and now we can find our x-intercepts. Let's find our y-intercept first. That's always going to be the easier one. All right, so the y-intercept is always going to be 0, comma, your c value. In this case, it's 0, comma 7. Right, and as you can see, 7 is all the way up here. Right, and you can use symmetry to find another point reflecting this. Right, so if we're 2 units from the axis of symmetry, let's graph 2 units over here. All right, and now let's find our x-intercepts. All right, so again, to find our x-intercepts, you're going to set your function equal to 0. So 2x squared plus 8x plus 7 equals 0. Let's try and factor this. There's something in front of the x squared. So remember, this is one where you want to try it by grouping, right? So we're going to do 2 times 7, which is 14. So we want factors of 14 that add to 8, right? Can we think of anything? Right, I'm actually not sure if this one factors. Right, doesn't look like it does, right? So 1 times 14 gets you 14, but it doesn't add to 8. 2 times 7 also multiplies to 14, doesn't add to 8. There's actually nothing that factors here. All right, so we actually can't do this. That means we need to use the quadratic formula, either the quadratic formula or completing the square. Right, so again, quadratic formula, anything involving quadratics, we're doing a lot of these in this course, right? So you cannot forget the quadratic formula. We're going to have x equals negative b plus or minus the square root of b squared minus 4ac over 2a, right? We know a, b, and c. We labeled it up here. So let's go ahead and compute this. This is going to be negative 8 plus or minus the square root of 8 squared minus 4 times 2 times 7 over 2 times 2. Right, so this is going to get you negative 8 plus or minus the square root of 64 minus 4 times 2 is 8. 8 times 7 is 56. Right, and then divided by 4. Right, and then 64 minus 56 is going to get you 8. So we get negative 8 plus or minus the square root of 8 over 4. right? Simplify this a little bit. It's going to make it a little bit easier. So you get negative 8 plus or minus 2 square root of 2 over 4. Right, so again, also don't forget how to simplify your radicals, right? This is going to simplify as the square root of 4 and the square root of 2. The square root of 4 becomes 2. All right, and then this is going to become, you can divide each of these by 4, right? So negative 8 divided by 4 is going to get you negative 2, plus or minus. 2 and 4 can simplify, and you get square root of 2 over 2. Right, so lots of work for this x-intercept, right? I know it's a lot of steps, right? And you doesn't look as nice as the ones that we've done before, right? But sometimes they do cross the x-axis at a strange point. It's not always going to be a nice whole number, right? So let's try and graph these. One way that you can think about it, we don't really need to be super precise with our points, right? As long as we know that it's going to cross our y-intercept over here, we can just graph it as follows, right? I'm not going to be super picky if it's slightly off by a little bit, right? And then square root of 2 over 2, I mean, you can verify using your calculator. It's not going to be that big of a number. I think it's a small decimal number, right? But another way to think about it, and I had taught you guys this before when we were doing our inequalities, right? You need to be able to reason through some of these problems, right? So something like this, you can kind of figure that it's going to be between, right, 1/2 and 2/2, right? So 1. Why am I saying this? Well, because we know that the square root of 2 is definitely going to be bigger than the square root of 1, right? But the square root of 1 is 1. And we know that it's going to be less than the square root of 4, right? And the square root of 4 is 2, right? So it has to be between 1/2 and 1, right? If you're not comfortable with that, that's fine. As long as you get your value, that's all I really care about. Another thing that I should mention, you don't have to write it exactly the way I wrote it like this, right? If you simplified it, but you still kept it under 1 fraction, right? So I'm gonna use a different color just so that you guys can see, right? So you could have done it as negative 4 plus or minus the square root of 2 over 2, right? That's perfectly acceptable as well. Yeah, I'm not going to be super picky about that. But to actually write down your x-intercepts, we're going to have, we can write down either one, right? So negative 2. I'm going to write plus or minus the square root of 2 over 2, comma 0. Right, and this accounts for both x-intercepts, right? They're going to be somewhere over here, right? So somewhere right there. This accounts for both of them. Another way that you can write it, guys, is if you were to do negative 2 plus the square root of 2 over 2, comma 0, comma, negative 2 minus the square root of 2 over 2, comma 0. Right, so you can write it separately. If you write the plus or minus in the same one, that's fine also. Right, but this is certainly one of the more involved problems, right, where it's not as straightforward as factor it, get your x-intercepts. But this is going to conclude the first part of this lesson, right? So this was really just focusing on graphing quadratics that aren't strictly transformational, right? So you're not going to use your horizontal and vertical shifting, your stretching and shrinking, your reflections. I mean, if they give it to you in that form, you can, right? But as you can see, this one and the last 2 slides, we weren't able to do that, right? So hopefully this helps.